Hey friends, over 9 billion microcontroller-based devices ship every year. More and more of these devices are connected to the internet. Azure Sphere is a solution for creating highly secured and connected MCU-powered devices. Now, when you combine Azure Sphere with the Azure RTOS, the real-time operating system, and Azure IoT Central, you can build real-time, capable, secured, updated, and internet-connected devices. Sound confusing? Fortunately, Mike Hall is here to show me how it works today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. Mike Hall, you look like you have a very interesting desk with a lot of cool stuff on it. I suspect that there's robots and blinky lights and IoT devices abound.
Yes, all of that exists, including the robot that you just
A
mentioned.
robot. I love it. Okay, I want to learn all about how Azure Sphere makes this possible and the kinds of great stuff that I can build today. So we could go right into the demo, but I know that there's some context that's important because when we say microcontroller, someone who's watching who may not be familiar, they might think, oh, like a Raspberry Pi. Maybe you could juxtapose briefly the difference.
Sure. So the Raspberry Pi and similar devices do run a type of processor. And a lot of these devices, and actually many phones that you may have, run some kind of processor. And a lot of these processors are designed by a company called ARM. And the company ARM has three processor architectures. They are known as A, R, and M, funnily enough. A stands for application core. So the type of ARM processor that you find on the Raspberry Pi or on your phone is an application class processor. That means it's capable of running something like Linux or Android or high-level operating systems. The R stands for real time, and that's the type of very low-cost sensor type product that you may find in the ABS system in your car, for example. And the M is a microcontroller, and the microcontroller is found in all kinds of devices, lots of devices that have simple buttons and displays, microwaves and toasters and refrigerators and washing machines, and anything that has like a display and buttons on it probably has some form of intelligence inside. So for Azure Sphere, and I'll just hold up one of the Azure Sphere development boards, this has a chip in the middle. That is the MediaTek MT3620. And this is interesting in that it has an application class processor, an A7, and two M4 microcontroller cores on it. So you can write code that runs on the A7 with a high-level operating system, and also run code that runs on the M4 cores, either as bare metal code that you write that just runs on the core directly, or based on some kind of operating system, for example, Azure RTOS as a real-time operating system running on that core.
Interesting. Okay, so if I'm thinking about building a car, I sometimes think, well, I have to choose between a motorcycle and a minivan and a sports car. But this is it's more sophisticated. I could have a minivan that pulls a trailer, and then there's a sidecar off to the side. And it's really this kind of vehicle caravan with different responsibilities and different pieces, but it's still the same object.
Right. Yes. So when you're building some kind of embedded system, a system that is based on Azure Sphere, you get to make that decision about what code is going to run on the A7. The A7 is the core that can be connected to the internet. So you might be connected to Azure services like Azure IoT Hub or Azure IoT Central or other Azure hosted services, or even services that you've created yourself or on AWS or some other internet hosted endpoint you want to talk to. The code that runs on the M4 is typically code that is real-time, deterministic in some way. So that may be talking to some kind of hardware device that has certain timing constraints around it. For example, in the case of the robot, this is a really good example of a device that it needs to be real-time, right? If the timing isn't right, the thing face plants, it falls flat on its face. So the way that we've divided the capability of this device is we have Azure RTOS running on one of the M4 cores, and that's reading all of the sensors. It has an accelerometer, gyro, magnetometer on board. It has lasers on board. You can't build a robot without lasers. So it can do distance sensing at the front and back. And all that code on the M4 is kind of reading the sensors 200 times a second. It's calculating the balance point of that robot to determine how fast it needs to move the wheels to keep the object balancing. Think of putting a stick on your hand. By default, the stick will fall over and you need to move your hand constantly to keep the stick balanced. In effect, that's what the robot is doing, right?
I see. So there's a responsibility principle here. You've got the application code, which really just needs an input from a model, and then the model is quite sophisticated. It needs to be calculated. So you separated the responsibility, not just in the software, but on two different chips.
Yes. So the M4 core only deals with reading the sensors, figuring out how it needs to adjust the motors, and that's it, right? It's dealing with the balance and control of the robot. The A7 is connected to the internet, so it can send telemetry. Here's my battery level, the position that I'm facing on a compass, how many obstacles I've seen on the lasers, these kind of things, and also take commands. So we could ask it to turn in a particular direction, and then it will send a message from the A7 core to the M4 core saying, if you can, turn to this particular direction. And the M4 can, based on its current inputs, how fast it's traveling, the direction it's facing, whether it sees an obstacle, decide to either turn to that position or not, depending on what it's doing.
Interesting. So that's a lot of good context. Let's see it actually happen, though.
Okay, so I think there's a couple of things to talk about.
All right.
One of the things we've talked about is the A7 and the M4, and both of those are running software, right? So at some point, as the application developer, I might want to expose some new capability, some new feature on my device, in which case I need to update the software on that device, right? And
that's scary, though, because it's a robot doing important things, right?
Yes, exactly. And also, Microsoft may want to update the operating system that's running on that A7 core as well. So as a real-time system, here's my robot. If I'm balancing away quite happily and I take an operating system update or an update to my code running on the A7 or the M4, that will interrupt the running of the system, in which case, device falls over and you don't want that, right? So what we have is a model on Azure Sphere that allows you to update your applications running on the M4 or the A7, or to take an operating system update on the device. And you can defer those updates. So you can be notified, here's an update. Do you want to take it now or do you want to delay it by some amount of time? So I've put together a demo that shows this working. And this definitely works on the robot. The problem with the robot, of course, is that it's balancing, and to keep its balance, it's constantly moving. So getting a camera on it while it's taking that update is a little tricky. So I've built a static version of that to show that capability. So why don't we take a look at that first, then we can go back and take a look at the robot doing its thing.
All right, let's do it. So if we switch here, you're in the corner now, and I'm looking at a thing that says Azure Sphere, and it's blinking busy.
Yes, so let me just increase the size of that for a second. So what we're actually looking at here is a display which is connected to an Azure Sphere development board. And the Azure Sphere development board has a reset button in the middle and two buttons either side marked A and B. If I push the button A, that can switch the mode of the device from being idle, I'm not busy, maybe that's a good time for me to take an update, to busy, which means that maybe I shouldn't take an update because I'm busy. So in effect, what I've done is built two applications. What we have now, as you can see in the top left corner, is App 1. And this is showing busy in the word Azure Sphere. And App 1 is an application that doesn't subscribe to these notifications about application or operating system updates. So if I update the application running on that device, it will just take that update and restart. For something like a real-time system like our robot, that's not the behavior that you want. You really want to do this kind of deferred update model. So I've got a command prompt here. And this allows me to execute Azure Sphere commands. So what I can do is just type a command here, which is Azure Sphere, device group, deployment, create, a device group ID, and then an image ID. So when you think about an image is basically an application that's targeted at the A7 or the M4. If I had two applications, one for the A7 and one for the M4, then I would have 2 image IDs listed. In this case, we're only updating the A7. In that case, there's only 1 image ID displayed. What we can do is update, in our case for this demo, just 1 device, but we can update all devices within a group at the same time. So all those devices get the same update. So what I'm going to do is just push that update. And what I need to do in order to update this device is restart the device. And the reason why I need to restart it is that the Azure Sphere devices will check for updates every 24 hours. And you know, the device has been up for a while, but I'm not sure when its next check is. So let me just restart the device. I can either hit the reset button or type a command, Azure Sphere device restart. And what that'll do is restart the device, and it'll come back up in the same application that it was in before. So this will still show application 1. And then over the next few seconds, it will get the update. It will take the update, apply the update, and then the device will restart automatically. The application will restart automatically into the updated application. Okay, any questions?
When you said restart, did it only
Yes.
restart because it wasn't busy?
Well, so in this case, the application is going to get updated. So an update will be downloaded to the device. The update will be applied. The current application will stop. The new application will then start. The device itself doesn't restart. It's only the application that is stopping and restarting.
So it's a soft restart, not a hard restart.
Yes, yes.
Okay.
Correct.
And the other processor still doing its thing, kind of just thinking about stuff that no one's listening to.
Right. So in this case, for this demo, I'm only deploying an application to the A7.
Of course, but like in the theoretical robot scenario, you know, there's 2 different responsibilities and 2 different things are happening. One of those processors can disappear, update itself, and the other one is just going to kind of be there suddenly without a head, and then the head shows up later and they reattach.
Yeah. So from an update notification standpoint, you know that it's either an operating system update or an app update. You don't know whether that update is an A7 or M4 update. So in our case with the robot, you still want to ensure that you're in a safe position and then take the update. And that could be updating just the A7 app, or it could be updating the M4 app, or both.
Oh, what happened? What's happening here?
So our device is now updated. We're now in the application 2. That's the application that we've just deployed. So you'll notice that the application is showing busy. So the state is maintained, right? The application is busy. And I can obviously hit button A and make it idle. But in our case, we actually want it to be busy, because what we're going to do is push another update to the device, which will then apply that update. But we don't want it to take it because the application is currently busy. Okay?
Yep, got it.
Right. So what I'm going to do now is just push out a different update, which is going to update the application again. Again, we need to restart the device because it's less than 24 hours. So we're not sure when the next check time is going to be.
And it's worth pointing out that when you're doing this update, when you go and say Azure Sphere, you're not talking over a COM port or locally, right? You're setting that up to the cloud and then it's being delivered over the air.
No, actually, in the case of the command, Azure Sphere device something. In fact, there is a whole series of commands that I can apply. In this case, the development board is plugged into my PC on a USB connection. So it does have a device address, and the Azure Sphere command. In effect, there are two types of commands that I can issue from this Azure Sphere command prompt. One of which is a command that affects the device directly. So I can say Azure Sphere device restart, or I can say Azure Sphere device Wi-Fi add to add a Wi-Fi endpoint connection onto the device. But there are other commands that I can apply to the Azure Sphere command prompt that don't affect the device directly, but as you mentioned, are going to the Azure Sphere backend service. So, for example, wanting the application update to be deployed is something that is is a cloud connection thing as opposed to a local device thing. So I'm not directly telling the device using this command prompt to update itself. What I'm doing is informing the Azure Sphere security service at the back end that this update needs to be applied to devices within this device group. Okay, so we now have that update ready to apply. So let's go back and take a look at that. So if we take a look at the display on the device, what we can see is it's still showing app2 and that the application is busy. And in the top right-hand corner, we now see like an update circle with a clock in it. That means that an update is ready to be applied, but we've deferred that update because the device is currently busy. In the case of our robot, the robot is standing up, it's balancing, it's doing its thing, right? So all I need to do now is just hit button A on the development board, and that will switch it from busy to idle. And so you can see the clock has now disappeared from the update icon. And then within a few seconds, that update will be applied, in which case the icon will change to an hourglass, which means the update is being applied, and then the application will restart into the new application that we've just pushed.
Interesting. So we're getting new capabilities as this gets upgraded. We're adding new features.
Yes, exactly. So one of the things we mentioned, and then interestingly, the application I pushed was application 1, right? the application that was running before. So in the case of the robot, holding up the robot again, maybe one of the things that we initially deploy with the robot is the robot running maybe without the time of flight lasers, the distance lasers to measure to look for obstacles. Maybe the initial release doesn't have those turned on, but we could apply an application update to then turn on those lasers as a new feature, for example.
That is slick.
Okay, so that is the update process. Now, why don't we take a look at the robot doing its thing?
All right, let's do it.
Okay, so I'm going to go back to the camera, and the camera's on a tripod. What I'm going to do is just turn this up so it kind of looks more at the desk. And I've just turned the robot on. Its display is just updating. It's showing power, Wi-Fi connectivity. It's just connecting to Azure IoT Central because the robot sends telemetry around battery and compass direction and number of obstacles the laser has seen. Okay, so I'm now going to stand the robot up, and the robot stands up, and it balances. It's doing its thing, right? You'll notice at the bottom of the display hopefully you can see this, is the letter B, and that means that it's running application B, which is the same as app 2 on the development board that we were looking at just a few seconds ago. So here's the robot balancing, and it will continue to do that. I can put my hand in front of the robot. Hopefully you saw the lights come on.
I saw the
which
laser.
Meant that, so the laser has detected my hand, and it then moved to avoid my hand. So with the robot balancing, this is connected to Azure IoT Central. And so in Azure IoT Central, we can see information about the robot. We can see its current battery level. We can see its heading, the compass direction. We can see the number of obstacles that it's detected on its laser, and also the current application that is running. So there we are. That's an Azure Sphere powered, hard real-time, self-balancing robot connected to Azure.
And that's the value of both real-time operating systems, multi-microcontroller systems, and Azure Sphere. The whole point is that there's this operating system, this ecosystem that you can count on. Microsoft can update the Azure Sphere stuff. You can update your application, and you can do it in a way that guarantees that it's not going to stop in the middle of the spin cycle if your IoT connected washing machine is or dryer or whatever is working. This is pretty cool.
Exactly right.
So folks can learn more about Azure RTOS. They can learn more about Azure Sphere, the Azure Sphere deferred updates, and how all of the things work that you built. And we're going to put the links in the show notes.
Sure, of course.
One question I do have, that development board, I can buy that, I can get a hold of that, and I can play with that. But of course, when I finally go into production, there's not a development board inside the robot, is there?
No, actually, let me kind of walk you through that quickly. There are various development boards you can just buy, today. So, here's the one that our display was connected to. This is made by a company called Seed. This is the MT3620, I think it's called RDB. They also have a mini version of that. That's this guy. Hold the two up together so you can see,
Right.
big and small.
Mini version there.
Yep. Avnet have a development board, which is this guy.
Yeah.
And this has a module on the side of it, which is kind of interesting. It also has these two click connectors on the front of the board as well. So you can get micro click boards, and there's about 1,000 of these click boards that you can just kind of click into here. And they also have a Grove connector on the side as well, which is this white connector, so you can put kind of Grove devices in there. All of the boards have pins on the front that you can connect things to. These are known as ISUs, I2C, SPI, SPI, and UART. So you can connect things on, serial connections, GPIO, general purpose IO, PWM.
So the whole point of that is that during your prototyping phase, you're basically playing with Lego bricks and you're just plugging things together. And then when it comes time to production, you've proven it on the development board. You've proven it with the different connectors, whether they be Grove or clicks. And then you go to production by putting the actual component parts on a board of your own design.
Yes, we started with this development board and then had each of the peripherals, motor controller, accelerometer, gyro, and so on, all connected to this so that we could prove out the software. And then from there, we designed and built a custom board based around that same Avnet module that you saw. And this has the lasers on there, the motor controllers. It has the display on the back. So we designed and built these boards to go in the robot. And we've got a designer on our team that designed the enclosure that the robot goes into, and that was 3D printed to take the board, which you can see, inside
there it is. Yeah.
of the device. And it's got 3 AA batteries on the top and the motors down in the bottom. That's the robot.
That's actually a really good point too. You point out that funny shape at the top, that hammerhead shark kind of thing that's happening at the top of the robot there. That's because it's not just balancing a piece of plastic, it's balancing a bunch of AA batteries, which are quite heavy, which is even more extraordinary when you think about it. Look at that.
There we are.
That's quite a bit of weight there.
Yep.
Fantastic. Well, this has been great. Thanks so much for chatting with me today.
Of course. Pleasure.
All right. I am learning all about Azure Sphere and making a Azure Sphere self-balancing robot today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.